O-levels wale stuff tha कि you had oxidation states, and I told you that the number of electrons gained and lost, they have to be equal in a chemical reaction, right? It's the electrons gained and lost in a redox equation, you have to balance it. Okay, we did several equations which were redox. Okay, for example, if you have Na losing 1 electron and Al on the other hand gaining 3 electrons, then Na has to be multiplied by 3 because you have to make the electrons gain and lost equal. So this was all about AS division. And that's all that you have done in electrochemistry so far. There's nothing so far which is new. Now the only difference now is going to be we have these reactions, right? So the difference we're gonna up. Okay, now we're going to start A2 chemistry. So I'm going to write a reaction. Okay, let's say, and I'm going to try and balance it. And I'm going to explain to you what you're going to study in A2 electrochemistry. Okay, now the whole topic is in A2 electrochemistry. One second. So A2 electrochemistry. So I'm going to put two elements in front of you. There's Na and there's Cl2, right? These two elements. And I said now what is going to happen is that the equation is not given to you. Okay, ab se pehle na O levels, AS everywhere, the equation was already and always given to you. Okay, so I've written down two elements, Na and Cl2. Can somebody tell me what is the redox reaction that's going to happen? What's going to happen to Na? What's going to happen to Cl2? If I put them together. Will Na gain electrons, lose electrons? What will happen?
Lose.
Okay, so it's going to lose electrons, right? It's going to form Na+1. And what will happen to Cl? Cl is obviously going to gain electrons, right? So we've made a redox reaction. Yeah, it's got double color 2Na, 2Cl. You can balance it. Remember, electrons gain and loss, they have to be equal. So this was very easy. You were able to make a redox reaction, okay? But this reaction, the only reason you were able to make this reaction was that you've studied this reaction. I mean, this is probably the first equation you learned to write. Okay? Na reacts with Cl2. Na loses electrons, it's a metal. Cl2 gains electrons. But what if you had some other substance? Let's say you had 10 2 plus and you had lead 2 plus. And I tell you, now tell me what's going to happen, right? Who's going to lose electrons? Who's going to gain electrons, right? So now the issue is that you have no idea, right? No idea who loses electrons and who gains electrons, right? So the point is A2 electrochemistry is kind of predicting what will happen. Okay, right now at the moment we have no idea what's going to happen. Okay, what will happen to 10 2 plus? Will it turn into 10 4 plus? Will it turn into 10? Okay, what's going to happen? Will it get reduced? Will it get oxidized? No idea at the moment. Okay, upar wale mein we had some idea, right? We exactly knew what's going to happen, but not in this one. So the point is in A2 electrochemistry you'll learn how to predict whether a substance is going to lose electrons, and you're going to predict who's going to gain electrons. Okay, we're going to build a system. Now, if I put two elements together, so if I tell you, okay, there's Fe3 plus, sorry, there's Fe2 plus, and there's MnO4 minus 1, Okay, so at the end of this chapter, you will exactly learn what will happen in this reaction. You will make the equation yourself. You don't need any help from outside. Like in this reaction, once you're done with the chapter, you'll know, okay, Fe2 plus loses 1 electron, turns to Fe3 plus. Mn on the other hand becomes reduced to Mn2 plus, and there's water molecules that are produced, right? And there's 5 of these, 8 of these, and 4 of H2O. So the whole equation and the whole balancing thing, you will be able to do it yourself. So the first question is, अब इसको आंसर करते हैं, who gains and who loses electrons? How can we know what a substance would want to do, right? So let's pick sodium. Let's pick something that is familiar. Let's pick sodium. But what does sodium like to do? Does it like to lose electrons? Or does it, Abdullah, on him, Mike. Does it like to lose electrons? Does it like to gain electrons? Okay, this one, it likes to lose electrons. We know it's one of the most reactive elements. Okay, so we know, so sodium ka hame pata hai, we know it's what it's going to do. So we know it really likes to lose electrons, right? So there's a high tendency for it to lose electrons. So my next question is that can we give it a value? Like let's say we know it likes to lose electrons, but how can we quantify it? How can we give it a certain value? Okay, if I want to compare it with potassium, let's say. So I've got potassium over here. But it's okay. Let's say the question is, does potassium like to lose electrons more compared to sodium, or does it like, because potassium is also a group 1 metal. Potassium would also like to, it's a very reactive group 1 metal. It would also form +1 ions. So the question is, does it even have an even higher tendency to lose electrons? Okay, it's more because it's more reactive, right? It's down the group. But you've got all sorts of elements, okay? So there's going to be confusion. Who likes to lose electrons, who likes to gain electrons? So how can we quantify it? How can we give it a certain value? So for that, this tendency to lose electrons and gain electrons, you quantify it by measuring electrode potentials, by making standard electrodes. Okay, so we make a system and we start constructing standard electrodes. What standard electrodes is that for this reaction, for example, the sodium one, and the first type of electrode is a metal metal usually in equilibrium with aqueous ions. Okay, so if you have a metal in equilibrium with its aqueous ions, that's the first type of electrode. So we know sodium likes to lose electrons. So what I'm going to do is, I'm going to take a sodium electrode. Let's say there's a piece of sodium. Remember, this is a very simplistic diagram. Reality may it's slightly more complicated, but this one is a simplistic version which is sufficient for now. What I'm going to take is, I'm going to take a piece of sodium. So here's a bar of sodium, and I'm going to place it in a solution that contains sodium ions, like an NaCl solution. And I'm going to wait what happens. Now, in this case, I already know what's going to happen. I know that what will sodium do? Sodium is reactive, and listen to this carefully. Sodium is reactive, so sodium starts to lose electrons So it starts losing electrons. And a lot of sodium ions are going to be produced. So immediately what will happen is the sodium metallic rod will start to dissolve. It will start producing a lot of sodium ions. Okay, because we know it's a very reactive metal. So lots and lots of sodium ions are being produced. You clear this first step? Is this clear? I mean, this is what sodium is going to do, right? Is that clear? Risha, clear? Naseeb, Omar, is this clear?
Yes.
Achha, then the next part. Achha, can somebody tell you, will this go endlessly? Like, when will this reaction stop? Like, will sodium continue to dissolve? And every time sodium loses electrons, right? So all those electrons, they're left behind. You can remember it's a metallic rod. So every time the sodium atom loses electrons, it turns into sodium ions. वो जो बाहर वाला electron है ना outer shell में, one of the electrons in the valence shell is lost. And the metallic rod is capable of metallic rod has delocalized electrons. So it will have more and more delocalized electrons because the sodium is continuously losing electrons, right? Achha, when will this reaction stop? Or will this continue to happen endlessly? Kab khatam hoga? Will all the sodium dissolve or will it stop before that? Anyone have any idea, Risha? Naseeb, over. Okay, Lisa, I mean that's also true. Like the sodium ions can't dissolve endlessly, right? There's a limit to the amount of sodium ions in the solution. You can't have that many sodium ions. So one thing is the solution might get saturated, that there would be too many sodium ions, that more sodium ions will not be able to dissolve into the solution. But there's another thing happening. Okay, every time sodium loses an electron, what happens to the rod? It becomes more and more, it becomes more negatively charged. So there's a negative potential that's building up. Okay, every time sodium loses electrons, the electrons, they accumulate on the metallic rod and the negative charge builds up. What's happening to the solution? The solution is becoming more and more positively charged. So there's going to be a limit to this negative charge. There's going to be a point. A point will reach where the negative charge would become very large, right? Okay, every time sodium loses electrons, more electrons accumulate on the metallic rod. So a point will come when the negative charge would become very large. And when it becomes very large, तो क्या होगा? What will happen at that point is that the ions will start getting attracted back to the negative charge. Okay, so initially, the ions were getting formed. But every time an ion was formed, the negative charge, it continued to build up on the metallic rod. Eventually, it reached a point where the negative charge is so large that it will start attracting the positive ions back. So that is the point where a reversible reaction will get established. Okay, although sodium will continue to dissolve, but the negative charge would be so large that the sodium ions, a reversible reaction hoga. The sodium ions will get attracted to the electrons back again. Okay, and a reversible reaction will build up. And it is at this point that no further sodium ions will dissolve, although they are dissolving continuously. But at the same time, they're getting attracted to the metallic rod back again. So the net quantity of sodium ions will remain unchanged. Okay, is this clear? Is clear? Yes or no? And there's not going to be any further buildup of charge as well. Every time an electron is lost, right, the reversible reaction happens and sodium ions gains the electron back. So the net quantity of negative charge would become constant. Once it's reversible, okay, whenever something is reversible in equilibrium, so the amount of sodium ions and the amount of electrons that are being produced, that will become constant. Okay, it's not going to change. Every time someone loses an electron, someone else will gain the electron back again. So what do you do at this point? You're going to take a voltmeter, take a voltmeter pakro, and attach that voltmeter to ground or earth or any reference point. We'll talk about the reference point later on. So you attach it there and you measure the voltage. And the potential that's built up would be a negative potential. In this case, it's minus 2.71 volt. That's known as the standard electrode potential. So it's the potential that is built up on the electrode. And this potential, is this clear that there was a lot of electrons accumulating on this, right? Is that clear? So a lot of negative charge got built up, and then the reaction became reversible because the negative charge, it came a point where the negative charge was so large that the sodium ions, they got attracted back again, and the reaction became reversible, right? It reached an equilibrium. So अब ये हो रहा है कि you got a negative potential on this, right? If you know voltage, if you've done physics, all you have to do is attach a voltmeter and measure the voltage, right? You know it's a negative voltage that's built up. There's a lot of electrons on it. So you measure the potential. It's going to give you a negative voltage because of the extra electrons over here. This voltage is your standard electrode potential. It's the potential that's built up. It basically measures how many electrons are accumulating on the electrode. Okay, so you got a very negative potential, and the reason you got a very negative potential was sodium really liked to lose electrons. There was a lot of electrons that were accumulating on the metallic rod because sodium lost so many electrons. बात समझ आइए कि there's a potential that's built up on this metallic rod. Is that clear? And this potential gives us some idea of what sodium likes to do. If it's a negative potential, then that negative potential indicates that whatever this substance was, it really liked losing electrons. That it lost so many electrons that there was a lot of negative charge on this metallic rod. So that potential helps us figure out what the substance likes to do. Okay, so I'm going to write this over here that a negative potential indicates that if sodium did not like to lose electrons, then there would not be a lot of electrons on this metallic rod. And the negative charge over here will not be very large. Okay, so a negative potential indicates that sodium likes to lose electrons. Is all clear, Umar, Abdullah, Nasib? And that's the key point. Remember, this is the key point. The whole chapter is this. Negative potential. Remember this. Negative potential, that means the substance really likes to lose electrons. And in a similar way, if I open the data booklet, where's the data booklet? So all these potentials are quoted in the data booklet for almost all metals. Okay? Let me just open this. So if you, can somebody answer? Will potassium be more negative compared to sodium or less negative? If I replaced this with a potassium electrode, will potassium produce even more electrons? Will there be even more negative charge on this metallic rod or not? So potassium will be more negative, right? Are we clear, Seep, Anisha? So opening the data booklet now. There's a page. So remember, all this data will be printed now with the question. You won't have a separate data booklet, okay? But all of this data is still valid. It's going to be with the question. So you can see over here, if you find sodium, where did I get the minus 2.71 voltage? I got it from here. Okay, sodium ions in equilibrium with sodium. It's got a potential of minus 2.71. That means negative means that the sodium really likes to lose electrons. So we can find out potassium as well. Potassium would be even more negative. This is potassium. Okay, so over here, this one is potassium with potassium ions. That's minus 2.92 volts. That's even more negative. Potassium se niche kaun hota hai? That's rubidium. I don't think rubidium is over here, but no, they don't have rubidium. They just had sodium and potassium. So moving on. Let's do an example of someone who likes to gain electrons. Okay, let's. So this is, remember, the first type of electrode. It's a metal with aqueous metal ions. Okay, we'll discuss this later. The second type of electrode, that's gas with aqueous ions. So there's a gas, and that gas is in equilibrium with its aqueous ions. So this one. And let's take the example of someone who likes to gain electrons. Let's talk about Cl2. Okay, I guess everyone agrees that Cl2 really likes to gain electrons, right? Although clear enough, Cl2 likes to gain electrons. Is that clear?
Yes.
So we know that Cl2 really likes to gain electrons. Okay, so we're pretty sure that Cl2, ulta nahi hona, Cl-1 doesn't like to form Cl2, but because if Cl-1 wanted to form Cl2, so our table salt will spontaneously turn into chlorine gas. It doesn't. Cl-1 is very stable. Cl2 turns into Cl-1. The other way, it's harder to do. I mean, you need to do electrolysis to reverse this, because a lot of energy is required for that. So the reverse is not going to happen. It's Cl2 that's gaining electrons, right? Achha, what type of electrode will you make? Now you've got a gas on your hands. So we've got a gas, and this is our aqueous ions, right? So since we have a gas, we would need a gas. I need to make an electrode now. And the first thing is, where do I put the gas? It's going to be put in a gas jar. So that's where my Cl2 gas is coming from. Where do I put the Cl ions? The Cl ions have to be so where do I put the Cl ions? The Cl ions are going to be in the solution. So there's this solution, and the solution has Cl ions. Because you got Cl ions in the solution. Now, for an electrode, I need a metallic substance. I need because if Cl2 likes to gain electrons, where would it gain electrons? Like who is it going to take electrons from? So for that, I'm going to place a platinum electrode inside the gas jar. So we've got a platinum electrode. So we've got a platinum electrode. Remember, it's a metal. Metal have delocalized electrons, right? I mean, a metal, remember, a metal is a good electrode. Why is it a good electrode? because this is what a metal looks like. Its structure, whether you already know this. What is the metallic structure? It's positive metal ions in a sea of. So it's a positive metal ions in a sea of free moving electrons, right? So if somebody wants electrons, it can gain electrons from the metal. If somebody wants to lose electrons, it can add its electrons to the delocalized electrons, right? So metal ki khas baat hai कि the charge can build up on a metal. It can also you can remove charge from the metal. You can add more electrons to this delocalized electrons, and you can remove electrons. So platinum, that's why it's good. So Cl2 comes in. Okay, so imagine tiny Cl2 molecules coming in. What will they do? They'll see electrons in the metallic rod, right? And they'll gain those electrons, right? So more and more Cl2 molecules are going to come in, and they're going to start. They're going to start gaining electrons from the metallic rod. So what charge will build up on the metallic rod over here? Kya hoga? Is it going to be positive or negative? Positive, right? So because the electrons are being taken up by Cl2, Cl2 is constantly gaining electrons. So the metallic rod will become electron deficient. There's going to be positive charge that will be building up on the metallic rod. So more and more positive charge continues to build up. The Cl2 will continue to gain electrons from the metallic rod. And what will happen to the Cl2? They'll start turning into Cl ions. So lots of Cl ions are going to be produced. So in this solution, the quantity of Cl ions will continue to increase. But will this happen indefinitely? So आपकी जो metallic rod है, it's becoming more and more positively charged, right? As Cl2 continues to remove electrons from it. But up to a point, at a certain point, the positive charge would become very large. There's going to be a very large positive. So at a certain point, there's going to be a very large positive charge. And if there's a very large positive charge, what will happen? The metal will want its electrons back. Okay, well, positive charge will become so big that it will take the Cl-1 and start pulling electrons back from it. Okay, because the rod is so electron deficient. So there will come a point where the reverse reaction will also start to happen. Okay, up till a point, Cl2 will continue to gain electrons. Every time a Cl2 molecule comes in, electrons are gained from the platinum electrode, and the platinum electrode would become more and more positively charged. But up till a point where the positive charge would become so big that it sees a negative ion, it will attract the negative ion and pull electrons back from it. So that's when a reversible reaction or an equilibrium is established. Okay? Yahan tak clear? Is this clear? Right? Shan, Seeb, is this clear? And that's the point where what do you do with you measure the potential. You take a voltmeter, you connect the voltmeter with the metallic electrode and measure the potential with respect to a reference point. Okay? So the potential over here will come out to be, I think it's 1.36 volts. ठीक है, इसको मैं formally define कर दूं. I'm just explaining right now, right? So it's going to come out to be 1.36 volts, which is given over here. Where's chlorine? This is alphabetically, so Cl is over here. Look at Cl2 in equilibrium with Cl ions. It's 1.36 volts. It's a positive value. So what does that mean? A positive value indicates that a positive value indicates that whatever substance you had, it really wanted to gain electrons. Okay, so positive electrode potential that means that the substance really likes to gain electron. Yeah, that is what is meant by a positive potential. So you're going to get negative potentials, you're going to get positive potentials. It all depends on if the substance really likes to lose electrons, a lot of electrons would accumulate over here and the potential would become negative. So negative ka matlab hai ki it really likes to lose electrons. Vice versa, if substance likes to gain electrons, so if the metallic rod, a lot of the element comes in, or whatever the substance is, it comes in and starts to gain electrons, and a lot of them, so the electrode would become positively charged. Okay? So you've got negative potentials, you've got positive potentials. Is that clear? And that solves our problem. Because the whole problem was, what do substances like to do? Whether they like to lose electrons, whether they like to gain electrons. This value would indicate what they like to do. This is 1.82. That's very positive. That means cobalt really likes to, cobalt C plus really likes to gain electrons. Okay, vice versa, this value is very negative. That means calcium really likes to lose electrons. It likes to form calcium ions, not the other way around. Okay. So based on these values, you're able to figure out what do they want to do. And it's going to be relative. Okay. For example, if I compare copper, which is 0.52, and iron, which is minus 0.44. So if you compare 0.52 with, so it's going to be a relative value. Okay, you're given two substances and you're going to compare their values. Who's going to gain electrons, who's going to lose electrons. So it's going to be, the values are going to be considered in relative terms, like compared to what? But just alone minus 0.91, that does not mean anything unless you compare it with something. Okay, if I compare it with minus 0.41, then that means the chromium that really likes to lose electrons compared to this other one, which is chromium 2 plus. So इसको पहले ना थोड़ा formally वो discuss कर लेते हैं, but hopefully the basic idea is clear. Where do you get electrode potentials? ठीक है? Is the concept clear? Just the concept. Forget everything else. Positive potential, negative potentials, right? And is that clear to everyone? Abdullah, Seep, Shan, Umar. So now I'm going to study this formally, like because there's going to be a lot of drawings involved, and there's going to be a lot of specific things involved. Okay, so I mean the main concept is just remember that positive means they're going to gain, negative means they're going to lose, and it has to be a relative comparison. It's always in comparison to something. Okay, sodium likes to lose electrons, right? Potassium likes to lose electrons even more, so it's a relative comparison, right? So remember, it's अकेले value का मतलब कुछ नहीं है, ठीक है? If it's a standalone value, doesn't mean anything unless you compare it with something. I'll do one last electrode just to finish this first phase. You can build electrodes where you can have aqueous ions which are in equilibrium with, there's a third type of electrode, okay? And we'll discuss this in detail later on as well. Aqueous ions in equilibrium with other aqueous ions. Okay, so we did a gas electrode, we did now this third one. These three types of electrodes are sufficient to represent all the equations that are given over here. We'll do practice later on, okay? Aqueous ions in equilibrium with aqueous ions. So let's say we're dealing with a reaction where there's Fe3 plus ions and there's Fe2 plus ions. And I want to figure out what will happen. I want to figure this out. Okay, what's going to happen? Does Fe3 plus like to gain electrons and form Fe2 plus? Or the other way around? Or is it Fe2 plus that likes to lose electrons and form Fe3 plus, right? So let's say I'm confused. I don't know what's going to happen, but both of them are aqueous ions. Fe3 plus is aqueous, and similarly Fe2 plus is also aqueous. Let's say both of them are aqueous, right? So what type of electrode will I make? What I'm going to do is I'm going to take a beaker and I'm going to put both ions in the same beaker. So the beaker will have Fe3 plus, aqueous, and it will have Fe2 plus, aqueous as well. Okay, so this is the third type of electrode. Let's say whatever is happening, whatever see मैं reactivity sees पर comment करता हूँ, ठीक है? Whatever is happening, you've got aqueous ions only, right? And I want to figure out क्या होगा, who's going to gain electrons. Let's say Fe3 plus likes to gain electrons. Where would it gain those electrons from? So you need an inert electrode. You need a source. So what you'll do is you'll add a platinum electrode. Okay, you'll add a platinum electrode. So if Fe3 plus likes to gain electrons, it will start gaining electrons from the platinum electrode, and the platinum electrode would become electron deficient. There's going to be a positive charge that's going to build up. Vice versa, maybe Fe2 plus likes to lose electrons. So where would it lose electrons? It's going to give its electrons to the platinum electrode. So there's going to be more electrons on the platinum electrode, and the platinum electrode would become negatively charged. So whatever happens on this platinum electrode. Okay? And we're going to wait for the potential to build. And once the potential has the electrode potential or the voltage has been built up, we'll measure the voltage. And that voltage will indicate what do they want to do. Agar to yahan pe, if it's very negatively charged, then that means Fe3 plus really likes to lose electrons. Vice versa, if the voltage over here is very positively charged, that means Fe2 plus really likes to Fe2 plus really likes to lose electrons. If it's if Fe3 plus starts to really gain electrons, it will be positively charged. If Fe2 plus likes to lose electrons, then the metallic rod would be negatively charged. So whatever happens, the potential that's built up over here will tell you. And the data booklet gives this potential as positive 0.77 volts. That kind of indicates that Fe3 plus kind of likes to gain electrons, which is why there's positive charge that's built up over here. So that's your third type of electrode. You guys remember, one second. I said this one. So remember this thing that in every reaction, you'll set up different types of electrodes. Either the electrode will involve a metal. In that case, the electrode would look like this. The metal would be over here and the ions will be in solution, and whatever happens, whatever goes on, a potential would build up over here, right? Then there'll be equations or reactions where there's a gas involved. If there's a gas involved, in that case, the gas will be in a gas jar and the ions will be in the solution, and you'll put a platinum electrode and you'll wait for whatever happens. A potential would build up and the potential will tell you what's going on. If it's positive, then that means it likes to gain electrons. If it's negative, that means the substance likes to lose electrons. And then there's a third type of electrode. Maybe the equation only has aqueous ions. In that case, if it only has aqueous ions, so the aqueous ions would be in the solution and the platinum electrode would be dipped into it. Whatever happens, the potential will build up and that will give you an idea of what's going to happen. Okay? You clear it? Three types of electrodes. Is that clear? We're going to practice this a lot more. But is this part clear? See, uske upar question ki reactivity sees. This is definitely linked to the reactivity sees, but the thing was the reactivity sees was very limited. Reactivity sees would tell you that sodium is more reactive than aluminium. Okay? One second. this one, sorry. This one is definitely linked to the reactivity series. Okay, what happens in the reactivity series is reactivity series, you know that it's K, N, A, C, M, G, L. You know that Mg is more reactive than Al, but you don't have any value. You don't have TKMG is more reactive than Al, but like exactly how much reactive, right? Plus the reactivity series. अब ये plus 0.77 means at the moment it means nothing. Okay, comparison it means if I compare it with chlorine. The chlorine is even more positive. Positive का मैंने क्या बताया था? I told you that positive potential means that the substance really likes to gain electrons. So if you compare these two, between these two, this is 1.36, this is 0.77. 0.77 indicates that it likes to gain electrons, right? But 1.36 means that Cl2 likes to gain electrons even more. ठीक है? तो अभी डिटेल में आते हैं, ठीक है? We'll discuss this in a lot more detail. अच्छा, लेकिन coming back to the sieve, remember it's related to the reactivity series, but the problem with the reactivity series is that it had very limited number of elements. Plus, there was quantitatively no value was given. Like we know aluminium is reactive, but exactly how reactive? Do we have a value for that? We didn't have a value. We just knew that aluminium, it's at the top of the reactivity series. That doesn't mean anything. That just means that aluminium is reactive. Like, but you didn't know like how reactive, right? You didn't have a value for that. Now you've got a value for that. This is exactly like the reactivity series where you had limited elements, right? But let's compare it with the reactivity series. You had K, right? K was at the top. K is over here. It's still at the top. It's minus 2.92. That means it really likes to lose electrons. It's more negative than pretty much everything apart from lithium. Then you had Na. Na was slightly less reactive, so that's minus 2.71. Then you had Ca. Ca would be slightly less reactive. Ca is over here. That's minus 2.87. Actually, Ca likes to lose electrons even more compared to Na. Actually, it's minus 2.87. But the trend we है, ठीक है? It's there's Mg. Mg would be slightly less. It's minus 2.38. So, बस वो है reactivity series में you didn't have a number associated with it, and you didn't have these many substances. So ठीक है, let's continue tomorrow. Next time we'll discuss in a lot more detail. ठीक है, we'll अभी just एक brief intro है, ठीक है? Just think of it as a very brief intro. But we didn't really cover much. So okay, everyone. Hafiz.
Allah Hafiz.